The following series that we are going to be discussing its convergence divergence is sigma from n equals 1 to infinity of factorial n squared over 3n factorial. Since we are dealing with factorials, clearly we have to use the ratio test. So first we start by calling the n term an, and we try to come up with an plus 1. So an plus 1, whenever you see n, you put n, but be careful. Whenever you see n, put n plus 1 between parentheses. Otherwise, this may generate some terrible mistakes, okay? So this will give me n plus 1 factorial over 3 times n plus 1 factorial, which is equal to n plus 1 factorial over 3n plus 3 factorial. If you did not put parentheses, some students may put 3n plus 1. So that's an plus 1, and now we have to find an plus 1 divided by an. Since an plus 1 is a fraction, and an is a fraction, so we have the top fraction over the bottom fraction, which is the same as the top fraction times the inverse of the bottom fraction. So we have the top fraction, n plus 1 factorial over 3n plus 3 factorial, time the inverse of the fraction that gives an, which is 3n factorial over n factorial. There was a square, sorry. Yes, so there is a square here. Square, square, square. So now what we're going to do, we're going to put this term above this term and this term above this term because they are of the same nature. So we have an plus 1 over an equal n plus 1 factorial squared over n factorial squared and 3n factorial over 3n plus 3 factorial. So the square over the square, it becomes everything, the entire fraction square times 3n over 3n plus 3 factorials. So now we use the algebraic properties of the factorial, so we know that n plus 1 factorial is n factorial n plus 1 squared, and the 3n plus 3 is 3n factorial, 3n plus 1, 3n plus 2, 3n plus 3. So now we can cancel the n factorials and the 3n factorials to get an plus 1 over an equal n plus 1 squared over 3n plus 1 times 3n plus 2 times 3n plus 3. So all this is purely algebraic till this stage. We did not start yet the calculus part of series at this stage. We just did a lot of algebra, and this is the hard part. So one has to be very careful to carry on the correct calculations. Okay, so now we are going to be looking at the limits, but when you do the limit when n goes to infinity, what we are going to do is keep, because this will be an expression of powers of n on the top and on the bottom, but we are going to only keep what? This one, this one, this one, and this one, which tells me that the limit of an plus 1 over an when n goes to infinity is the same as the limit when n goes to infinity of n squared over 3n times 3n times 3n. So this is the same as limit of n squared over 27 n cubed. We cancel the n squared and we get limit when n goes to infinity of 1 over 27 times n, which is 0. Since 0 is less than 1, then the series n squared, n factorial squared over 3n factorial is convergent by the ratio test.